Why is it so important to plan your sample size? Well, one pragmatic reason is that funders demand it. For example, in 2016, the National Institutes of Health revised the application and review process for better rigor and reproducibility. Reviewers are now asked to assess if the project is designed to produce robust and unbiased results. And sample size planning has been lifted up by the NIH as a key technique for ensuring robust and rigorous results. Journals and professional societies have also begun asking for sample size planning. In 2014, the National Institute of Health convened a meeting with stakeholders to hammer out best practices for reporting preclinical research. One of the principles that emerged is that authors should always report their sample size determinations. So now, for example, if you submit to Nature Neuroscience, you will complete a reporting checklist, and the very first item on the checklist is to justify the sample size used. The Journal of Neuroscience quietly implemented similar policies as of March of 2018, asking researchers to justify their sample sizes within their manuscripts. In theory, all 81 of the preclinical research journals that signed off on the NIH guidelines should have implemented policies that require sample size plans to be clearly reported. Now, we need to respond to extrinsic mandates, but fortunately, there are also good intrinsic reasons to engage in sample size planning. First, there's an ethical obligation as a scientist. For example, the American Statistical Association has ethical guidelines for those who regularly use statistics. These guidelines stipulate an obligation to ensure that data collection is adequate, that we should not collect too little nor too much data. Why is this an ethical obligation? It's because sample size planning is actually essential for good science. Without a plan, it's unlikely that you would collect exactly the right amount of data. You could end up collecting too much, which is problematic because it's wasteful and needlessly risky for living participants. More likely, though, you could end up with an inadequate sample, and that is really bad. Inadequate samples are uncertain samples, meaning that they don't give us enough information to draw firm conclusions. So that means you can do the study, spend the money, sacrifice the animals, but the data won't actually answer your question, and that's a huge waste. And the scary thing is that this can be true regardless of the p-value. Even if your results are statistically significant, if the sample size is inadequate, the results are likely to be misleading and unreplicable. We'll discuss this more in the next section. Finally, sample size planning is not just a necessary ingredient for good science, it can be a catalyst, a skill that can help you conduct amazing, fruitful, and generative science. We'll discuss that in the last section of the workshop.